In previous classes, I hope you have seen about NLP pipeline. I have discussed in very detail what are the different pipeline, because it's very important to understand the concept first. Okay, so in this class, if you have gone through the previous lecture class and you have better understanding about all the pipelines, all the steps involved in a NLP task, right? So in this class, we're going to touch upon an important part of the step, which is called data pre-processing or data normalization. Okay. So what is data pre-processing? How to perform data pre-processing? What are the steps? Okay. Those things we're going to cover. And here, to perform data pre-processing or data normalization, we have to use one library. Okay. There are multiple libraries, by the way. So here in this class, I'm going to cover NLTK. If you can see that, it is called Natural Language Toolkit. Okay, so we will see that how NLTK help us to perform text pre-processing, text normalization, those everything we will cover. Okay, and then once we have the concept, then we will try to solve some problem using NLTK. Okay, so on this note, let's start and let's understand what are the capability of this library NLTK provides us and how to use it, its different API. Okay, so first of all, let me explain what is data pre-processing. I hope you know that. Okay, so if you have seen the previous video, I have talked about what is data pre-processing. What happens once the data comes into our system? Okay, generally more than 90%, I would say 99% cases where your data won't be clean, your data is not perfect. There could be multiple problems with the data. Maybe data has some special character, data has something which is not required, some unwanted character. It can be n numbers of things which we will see right now. Okay, so before building any kind of model, any NLP model, any kind of model, the first step which is very important is cleaning the data or data pre-processing. Okay, so how to do that? We have to use a lot of library. One of the library is called NLTK. Okay, you can see that it has we have a lot of options. We have NLTK library and it is very popular nowadays. And another library is a Spacey, and nowadays Spacey is more popular. Okay, it is completely optimized, it is very accurate library, and it has a lot of transformer based model. They use a lot of pre-trained model. And yeah, so I'm going to cover NLTK and Spacey. Apart from that, there's another library called TextBlob, Gensim, Pattern, Polyglot, other lot of library. Okay, so I will cover in this class NLTK, Spacey, and there is one more library which I have not covered here in this list. Let me just add here, which is also very good handy library. Okay, for NLP work. This is called unstructured. What is it called? Unstructured IO. Okay, I will cover that. Okay, I will take a separate class on that. Okay, so these are a couple of library, my friend, where I can use these all things. So, but here I'm going to cover about NLTK. What is NLTK? And how to get started. Okay, and what are the features of NLTK to help us to perform data pre-processing. So the first step is that you have to install NLTK. Okay, or you can go to NLTK website, NLTK. Okay, just type NLTK. So this is the official website of NLTK. Okay, and you will find a couple of good tutorial there how to use it. And another library is called, I was talking about Spacey, which I will cover in this course. Spacey. Spacey is also very good library. I have used it. It is pretty good, and it has a lot of new features, and you can fine tune the model. So this is called a Spacey. Okay, it has really good, cool features. I will cover that. It has a lot of pre-trained model, transformer model. Okay, and it performs really very well. So I will cover in detail how to use the Spacey model. Okay, but right now let's switch to NLTK. What is NLTK and how to use it? Right. Okay, so the first thing you have to do, my friend, you have to install NLTK. So how to get started? Just this is the thing you have to do. Pip install NLTK. Okay, and it will install all the NLTK library which is required to perform our job. So let me it is just installing it. I think, yeah, it is doing right now. Okay, cool. So it got installed. It is still doing. Just wait for some time. It is very fast, by the way. So this is the first step in your project. You have to install NLTK, right? Okay, it is still okay. All right. So it got installed successfully. Okay. After that, okay, one thing I want to cover: NLTK has a lot of modules, or you can say a lot of collection. Okay, it has multiple collection. uh, that and which collection you use for your work, that depends upon the case study, depend the problem statement. But here right now what I'm doing, I'm downloading all the collection. It has multiple collection, it has multiple corpus. I will talk about in going forward. Okay, but right now, to get us started, let me download all the modules or all the corpus which is available inside the NLTK. So this is the statement: import NLTK, NLTK download all. So it will download everything. Maybe yeah, maybe maybe you don't require all the module, but here I'm just for sake of teaching you, I'm just installing all the module. Maybe not everything is required, but let us download it. So it will take couple of minutes, it will take some time, not much. So you can see it is there, a lot of packages, a lot of corpus. Okay, a lot of modules are there. It is downloading everything like stammer, grammars, lexical packages, helper. There are a lot of things. So I'm just installing everything. Okay, so I think it is done. Yeah, this is done. So this is a prerequisite 2 steps. First, to install do a pip install, make sure your libraries are available, and you can download all the packages using nltk.download.all. This is prerequisite. Okay, now let's start our pre-processing work. Okay, so what are the different pre-processing are required on the data? As I told in the beginning, you don't have to trust on the data. Whatever data coming into system, it is not 100% pure. We have to do a lot of processing. So the first processing, which is very simple to get started, is tokenization. Okay, what is tokenization? uh, there are multiple there are different types of tokenization. So what is tokenization? Okay, let's suppose you're getting a sentence. For example, let's suppose this is one text. Let's suppose it is coming from files, some pdf, some text, right? I want to convert this whole bunch of sentence or this paragraph into small word or a small sentences. Okay, it is called tokenization. This process is called splitting the entire corpus or entire text or entire sentences into small chunk. This chunk can be a word. I mean, you can split the whole thing into a small word, or you can split into a sentence. There could be multiple, there could be two possibility. Okay, so let us talk about what are the different kinds of tokenization are possible. So first thing is called sentence tokenization. Okay, it's very as the name says, it's very simple. So here what I'm trying to do here, whatever text I have which is coming from external sources, I want to convert this whole, I mean, I want to split this whole sentences, whole paragraph into individual sentences. Okay, so if you know the English language, for example, suppose this. So till here, this is the first. For example, I'm writing here. NLP is a field of computer science, artificial intelligence, and computational linguistics concerned with the interaction between computers and humans' language, and in particular concerned with the programming computers to fruitfully process large natural language corpus. Challenges in, yeah. So till it, you can see here, starting from here to till, we have a comma and we have a full stop, right? So this is if you know English. Okay, so how we separate two sentences using this using comma, right? So here this will be considered as a first sentence, right? And after the comma, this is my second sentence, right? So here, let's suppose I have multiple bunch of text and I want to split the entire text on the basis of sentences. Okay, so in that case, you can use sentence tokenizer. I hope you got the point, right? I want to split the entire text, entire corpus, entire document on the basis of sentence. Okay, in that case you have to use sentence tokenizer. So how to use that? It's very simple. This is the code. You have to import this sentence underscore tokenize. This is the library which comes from NLTK. So you have to write this statement. Just import it. Let's suppose this is my whole bunch of text. Okay, and here I'm just using this function called sentence tokenizer and just passing my whole text. This is very simple. See, the coding part is very simple. You don't have to, this is one thing I want to add here. You don't have to memorize the entire code. This whole code, you can get it from internet or chat GPT. You don't have to worry about it, okay? The thing here, what you have to cover is the concept. Okay, so try to build the entire concept. If somebody asks you what is tokenization, so you should have a better understanding. Okay, these are the different types of tokenization. Okay, so try to build the concept here. Don't try to memorize the code. Coding is not a problem. Okay, so here I'm using sentence tokenizer. Okay, I'm passing this text. Okay, so this sentence tokenizer, this function will split the whole text into multiple sentences. So for example, in this case I have only two sentences. This is the first sentence and this is the second comma. So this is the two sentences. Okay, so here I got all the sentences, and now after these sentences I just want to print all the sentences. So I'm just using a looping. I hope these are simple Python code. I hope if you know the Python, it is not a bigger problem. Okay, so I'm assuming that you guys know the Python. So I'm just explaining the concept. Okay, I'm not going to explain the Python code. Okay, I hope you have the better understanding. So I got all the sentences. I'm just enumerating it and I'm looping it. I just want to get the index. That's why I'm doing enumeration here. So it will give me index and sentence, and here I'm printing that, okay, what is the index? I just want to count the number of sentence. That is why I'm using enumeration. Okay, so it will give me index as well. So let me run this code. It's very simple. You can see that. So syntax index 0. I mean that this is the first sentence, right? So till here, I mean, I told that this is the first sentence. So till here, it is the first sentence, and after challenges till therefore here, this is the second sentence. Okay, so in my in my source, in my text, I have only two sentences. So this way it will help you to split the entire text into multiple sentences. Very cool, very simple, right? So this is my first index. I mean, this is my first sentence, this is my second index. I hope this is very clear. It's very simple, right? Second is, no, I don't want to split only per sentence. I want to split per word. Okay, for example, in this sentence there are multiple words. For example, natural language processing, NLP, these are the individual word. So I want to go at very depth level, not only the sentence level. I want to split everything on the word level. So how to do that? No problem. We have a word tokenizer, just like a sentence tokenize. Okay, we have a word tokenize. So it will convert the whole text, whole word into all the source into word. Very simple. Okay, so again, same thing. This is my text, this is my source of data, and this data I'm passing into word tokenize, and this will give me a word, all the individual words. Okay, so here my intention is just to loop. I just want to print all the words. This is my intention. So you can see that if I run this whole bunch of code, it will give me entire words in the given text. So the word number 0, okay, you can see that natural. So natural is one word, right? Natural. Language is second word. Processing is third word. Then this is also this special character, this opening parenthesis, this is also considered as a word. Okay, then NLP, this is a next word. Then closing parenthesis, this is another word, right? You can see that is, so everything here, what I'm trying to do here, I want to get all the words which is a part of my data. Okay, and then I can suppose I want to perform something on every word level. I want to do some pre-processing, something we will see later. So this is very handy. Whenever you want to get the entire word, individual word one by one, you want to process individual word one by one, in that case this will be helpful, word tokenizer. Okay, I hope you guys are with me, right? So first we saw very simple sentence. The sentence tokenizer, it will split the entire data on the basis of individual sentences. Second was the word tokenizer. I want to see at every word level. I want to split all the words one by one. These are two important things. Okay. Next, okay, there are two more tokenizer. It is called white space tokenizer. Okay, how it works? It is more like a word tokenizer. It also split the whole thing on the word, but here the strategy is different here. Okay, in case of white space tokenizer, it split the text based on white space character. They have a different strategy. Okay, they follow this strategy. They will split the entire text on the basis of white space. For example, spaces. Suppose you have multiple spaces, you have multiple tab, you have multiple view line. So they consider while splitting the whole text on the basis of white space. Let me give example. Very simple. Okay, so very simple. For example, let's suppose this is my text. Hello, how are you? Okay, you can see that hello and how the between hello and how there's a tab, right? There's a space. And how are, between how and how there's a space, and between r and u there's a space, right? So these are the space, right? These are the space, these are spaces. So let's suppose I want to split. Again, it will give you a word. Okay, this is just like a word, the previous one. Okay, but here the whole but here the strategy is a bit different. It is it is a splitting on the word on the basis of what? Spaces. Okay, so if I run this, so we have to use this is a library white space tokenizer. Okay, and this is a I'm just creating the object and just calling the tokenize function. Okay, the coding part is very simple. Just try to understand the concepts. Okay, so here in the white space tokenizer, what is doing it is considering the white space to split the word. Okay, in case, okay, you might be thinking what is the basic difference between word tokenizer and white space tokenizer. Okay, so let me explain that. In case of word tokenizer, what happens? Everything, even this comma will be considered as a word. Okay, let me try this. Let me give the for example, suppose, let me try the whole thing. Let's suppose here words for the word tokenizer. The strategy for word tokenizer is that it will consider everything as a single word. Okay, so that's what I don't want to do here. For example, let's suppose I'm using this. Okay, and this is my text. Okay, so let us see the difference. What is the difference between word tokenizer and white space tokenizer? So this is my text, right? And I want to tokenize, right? Suppose word tokenize and passing that text. Okay, and let us print it. So let us see what is the difference you will get it, right? Okay, so you can see that what a difference here. In case of word tokenizer, hello is one word. They are splitting on the basis of individual word. So they are considering hello is one word, right? And this comma, this is also another word. How is another word. Are is another word. You another word, and the question mark is another word. So here every I mean, they're splitting on the basis of word. I hope you get it right. But in case of white space, what is my criteria to split the word on the basis of white space? So hello, this whole hello and comma, it's one part. In case of white space, hello and comma will come along with one part. But in the word tokenizer, they will be separate because they will consider everything is separate word. Okay, so I hope you got the basic difference. So in case of white space tokenizer, the criteria, the strategy to split the word on the basis of white space. Okay, but in the word tokenizer, everything is word, individual word. I hope you got the difference, right? Similarly, we have just like a white space tokenizer, which have that strategy. We have another tokenizer which is called punctuation. Okay, so white space, they split the word on the basis of what? White space or tab. But in case of suppose I have some punctuation. Okay, so the strategy for splitting the word in case of word punctuation tokenizer is the punctuation. They separate the punctuation. Okay, they okay, so they split the text into word. See, this is also split the text into word, but also separate punctuation. Okay, so this is a little bit you can say advanced. Okay, for example, let us see that. So I'm importing a word punctuation tokenizer, and this is my text, the same text, hello comma how are you question mark. Okay, so here what are the punctuation here? See, this comma and the question mark, they are the punctuation, right? So they are splitting hello separately, comma separately, how are you, and question mark. Okay, so they are considering the criteria here is what, the on the basis of punctuation, right? So it is more like a, I mean, it is more like a word tokenizer, but here they are different. They are based on the punctuation. Okay, so this is a basic difference. Okay, but generally uh, yeah, these are some special category like white space or punctuation based splitting. Otherwise, in generally we use word tokenizer. Okay, let's suppose I have seen the most of the time we use in our pipeline word tokenizer, where I want to split the entire whole thing into simple words. Okay, and then we will perform some further operation on each word. So I would prefer use word, because I have seen most of the cases in our project we mostly use word tokenizer. We get all the words, and then on top of each words we perform further action. We will see later on. Okay, but yeah, these are some different options. So we have these are the options. Sentence tokenizer is one option, where you want to get the entire sentence. You want to split on the basis of sentence. Second is the word tokenizer, if you want to split the whole text on the basis of individual word. Third is the white space tokenizer. You want to split the whole text into on the basis of white space or punctuation. These are the four options. Okay, but generally I have seen we use mostly sentence tokenizer or word tokenizer mostly. Okay, and then we perform some further operation. Okay, so guys, I hope you are with me. You got the concept of how to use tokenizer. Okay, these are the whole concept. Okay, now let's move to the next part, which is very important. Stop word. Okay, so in the okay, what is the concept of stop word? Stop words are like if you write any especially in the English, right? If you're writing any English sentences, we use a lot of like supporting verb, like not verb, like a supporting verb, like a, and, the, is, are. These are connecting words. Okay, they are connecting. Maybe these words has no such meaning. Okay, uh, for example, if I'm saying that apple is a fruit, apple is a fruit. So here is, apple is a fruit, here is and are. Okay, these are supporting kind of words. They are supporting, they are giving some they are connecting the each words. But if I instead of saying apple is a fruit, if I say apple fruit, let's suppose if I write apple fruit. So if I write only apple fruit, it is also giving some meaning, right? I mean, I'm talking about apple as a fruit. Okay, so in some cases what happens, because why we remove the stop words in some cases. Okay, because these stop words are, maybe they are no much so powerful, though they have no carry so much meanings in the text. And sometimes, not always, sometimes we consider, okay, let me repeat it, we sometimes consider to remove the stop words because of maybe it is taking a lot of space. Suppose we considering all the stop word and we store in our database, it will take a lot of memory, right? And even suppose these stop words are not very important or significant for our problem solving. In that cases we remove it. Okay, but not always. Just this is very important, my friend. We not always remove stop words. Okay, so in which cases we remove it and which cases we not remove it. Okay, whenever you're doing some text translation, let's suppose you are converting from one language to another language. Okay, so translation, even the stop word has important meanings, because for the translator they want to understand the contextual meaning from the stop words. In that case, don't remove the stop words. Okay, let's suppose you're doing the summarization. So in the case of summarization, those stop words also are very important to just get the context of entire word, entire sentence. Okay. In the sentiment analysis, let's suppose you have a performing classification program like sentiment. Suppose you got some reviews about the product, like from Amazon, like Flipkart. You got a lot of bunch of reviews, right? So these all reviews, this even the small words, this carry importance. Okay. So if you remove those stop words and performing sentiment analysis, maybe the meaning will be different. For example, let's suppose if I say, suppose I have two statements. Okay, I'm saying, let me okay, one second. Let me share this. Okay, suppose if I say that, uh, like suppose I write I love Python. No, let me like this. Okay, I love. Okay, suppose I love Python. Okay, or suppose I don't love Python. Okay, let's suppose I have two sentences. Okay, I love Python and I don't like Python. Okay, and suppose I am doing some sentiment analysis. Okay, so if I say I love Python, what do you think? What is the sentiment? It's a positive sentiment or negative sentiment? It's a positive sentiment because you're loving Python. Here, if somebody say I don't love Python, so what is the sentiment? It's a negative sentiment, right? So it's a positive and negative. But let's suppose I got these two texts and I perform some. Suppose I remove stop words. Okay, so after removing a stop words, okay, let's suppose I remove stop words. So this statement, I love Python, it will look like, okay, I love Python, let's suppose, because love is a verb, so this is not a stop word. So it will it will remain the same. Okay, but in the second case, if I remove, because see the don't, okay, so don't is a stop words. So if I remove don't, let's suppose, after remove it, so how it becomes I love Python, right? I love Python. So the machine will understand that it is still a positive sentiment because you have removed don't from this sentence and you're doing analysis, sentiment analysis. So for the machine, they will understand, okay, it's a positive sentiment, right? So in this case, sometimes it is not always best practice to remove stop words. Okay, so when to remove stop words? Suppose you're doing some classification problem, okay, where where your stop words is not much important, it does not carry much importance for the context. Okay, in that case you can go with you can remove the stop word. But generally I have seen uh, it is not a good I mean, generally, if you even your stop words has some important in your context, it is a best practice, don't remove it. Okay, so this is some scenario I'm going to I discuss. Okay, but let's suppose I want to remove a stop word, so how to deal with that? So that's what let us understand. Okay, so how to deal with the stop words? So there are some code for that. Okay, so stop words is the part of corpus. Okay, NLTK has multiple corpus. Okay, so it's a part of corpus, so we have to use import NLTK, and from nltk.corpus.import stop words. Okay, so if you importing this stop word, you will have access to all the stop words. Okay, and here okay, so NLTK support more than 17 language. Okay, so this stop words is totally depends upon the language, what kind of language you have. Suppose you have English language, so English language has a different way to interpret stop words. Let's suppose you're working with French language, you're working with Spanish language, maybe you're working with Hindi language, maybe you're working with the Spanish language. So every language had its own way to interpret stop words. Okay, so here NLTK support that. Okay, let's suppose, for example, in case of English. Okay, so first of all you have to get all the stop words. Okay, so how to get all the stop words which NLTK support for English language? So this is the things you get the stop words. Okay, and then call stop words dot word and English. You have to pass the language, for which language you want to get the stop words. Okay, so if you run this, so okay, you can see that I'm using I just want to print the length, what are the total stop words supported for the English language by NLTK. So it has only 198 kind of a stop word. So these are the stop words. Okay, a, about, above, after. You can say there are some couple of stop words, okay, which can be removed from the text. Okay, so for example, French, I want to see for the French language. So this is a stop word for French language. These are the stop words for Spanish language. Sorry. So every language, you can see that every language has a stop words. Even English, okay. Nowadays, it's a mixture of English and Hindi. So even English has 1,000 stop words. Okay, these are some set of stop words. Okay, apart from these stop words, again, these stop words totally depend upon your project. Okay, so let's suppose you have some specific requirement depending upon your data set, that you want to have your own set of stop words. You don't have to depend only the English language. Okay, you want to add something which you're considering that for my data set, for my domain, for my vertical, for my business, this can be considered as a stop word. This is completely depending upon the vertical, upon the domain. Okay, so you can prepare your own data set on stop words. This is up to you. Okay, let's suppose I got this stop word. Okay, I can add on top of that in this set, in this list, I can add my own stop word. Or you have a complete freedom. You can create your own list of stop words, and then you can deal with it. This is completely your choice, and I have seen that totally depends upon the use case. Okay, but suppose you want to deal with English, so by default they provide you this stop word. Okay, so let's suppose I got all the collection of a stop word. Then what next I have to do? Okay, okay, one more thing, guys. Apart from NLTK, there are a lot of, for example, a specie. Okay, even a specie has its own collection of stop words. Even you can see sklearn. Okay, even if you know machine learning, even sklearn has its own pool or collection of a stop word. How to use that? See the feature. This is the code scalan dot feature extraction, import stop words, and you can get all the stop words which maybe which scalan support. Okay, so these are the stop words. Okay, so generally I have seen the practice, we combine let's suppose I can take a stop word from a specie, I can take a stop word from NLTK, or I can have my own list of pool, list of stop words. This is, I told, this completely depends upon your business case. Okay, okay, so let's suppose I have the collection, I got all the collection of a stop word. What is the next thing we have to do? Let's suppose I have decided, okay, this is again optional. If you have decided that based on your business problem, I want to delete, I want to remove my all the stop word. So how to do that? It's very simple. Let's suppose I'm giving one example. So here I'm importing all the stop words. Okay, and this is my sentence. Let's suppose this is my small sentence, and from this sentence a lot of cough today. Okay, let's suppose this is my sentence. Okay, and from this sentence I want to remove some stop word. For example, is, this is stop word. A, this is stop word, right? Of, this can be stop word. The, this can be stop word, right? So let's suppose I want to just remove this unnecessary stop word for my business problem. How to do that? So here I'm getting all the set. Okay, this way I'm pulling, or I'm creating my own set. Okay, here you can add more, as I discussed earlier, right? Depending upon your use case, you can add more stop words. Okay, and then here I want to perform some action on each word. I told, right, I want to get each word from this sentence, and I want to apply, I want to see, I want to apply filtration on each word. So how to get each word? We have to use word tokenization, right? Just we covered in the earlier section. So here what I'm doing for this whole text, I'm applying word tokenizer. I'm getting each word one by one. Okay, so I got all the tokens, word tokens, and here I'm just applying a list comprehension. I hope you understand the Python, right? So what I'm doing here, I'm just iterating all the tokens which is a part of this sentence. right? So this part is the looping part, okay? And here, this I got the each token, each word, and then I'm converting into lowercase, and here I'm checking, okay? I'm just doing a filter from this whole text. I'm just doing a filter if this text which I got, it is not in a stop word. So I will consider, suppose I got the whole individual text, and I will consider only those texts which is not the part of my stop word. Simple logic. I hope you got it right. It's a very simple logic. So I'm iterating each word for my given data. And if I find that this text, this token is not part of my stop word, then I will consider it. This is what I'm doing. It's very simple logic, simple Python logic. Okay. So basically it is a filtration. I'm applying a filter on my given words, which is not the part of stop word. I'm considering them. I'm taking them. Very simple. Okay. So this way you can filter out your all the stop word from the given sentence. I hope you understand. It's very simple logic. Okay. Let me run this. So this is the world. Okay. This is the original tokens. Okay. For example, this is a sample sentence, comma, showing off the stop word filtration. Okay, so in this is or a is removed because it's a stop word. So even this is a stop word. So this whole three has been removed. Okay, now I got sample sentence, right? Even I have comma. It's okay. Showing, okay. Off is removed. It's a stop word. The is removed, is a stop word, right? A stop, we are taking a stop. Words, we are taking stop filtration. Okay, so you can see that it has removed nicely all the stop words depending upon my my pool or my collection of a stop word. Okay, so this is how it will works. Okay, so it's very simple. Okay, I hope you understand the logic. Okay, so the logic is, first of all, you have to prepare your own set of stop word. This totally depend upon the business to business case. Okay, and maybe by default NLTK provides you list of English stop word. It support multiple languages, so you have to prepare that list. You can add here more list depending upon your problems, and then you just do apply the filter function, do filtration, and you will get the words which is not the stop words. Very simple. I hope you everyone got this whole concept, right? Okay. What next? Okay, so what we can do next, we can do a lot of things. Okay, so we can remove punctuation, we can remove some spatial symbols, we can remove some spatial mark. Okay, this whole thing again, this whole thing depending upon your data, what kind of data you have. Okay, and one more thing, guys, uh, if you really want to clean your data, because my whole purpose is what I want to clean the data. Let's suppose I have some special character, I have some digit, I have some emoji in the my text. Okay, I want to remove everything. So generally we use, also we take help of regular expression. Okay, so Python has a module called RE. I hope you know that. Uh, if you have the basic knowledge about Python regular expression, it will be very handy. And especially in the NLPK, in the cleaning part, if you really want to work on the cleaning of the text, so a regular expression plays very important role. Okay, we extensively use RE module of Python. Okay, so here how it works, again, that totally depends upon your data. Okay, suppose I have some pattern, suppose I found that in my text data I have some special pattern, I observe a pattern and I want to remove that pattern. Okay, so in that cases you can use RE module. And how to do that's very simple. You have to use substitute function of RE module. Okay, and I hope you guys understand what is the RE module. Okay, I'm not going to teach those Python module. Okay, I'm assuming that you know that. Okay, so simple, create a pattern, regular expression pattern, and whatever pattern you find it, replace with the word or with the text you want to replace. Okay, so this function substitute is doing the same thing. So it will first find the pattern, and if it find the pattern, it will replace those pattern with this text, whatever you can pass here. Okay, for example, let's suppose this is my text, remove this, suppose this is my source of text. Okay, and this text has a hashtag, Again, this totally depend upon data, what the data you are dealing with and what you want to delete. Okay, so in that case, patterns play important roles. For example, here in this data, I want to remove the data, the word which is starting with hash. Suppose I want to remove this because it has a special character hash. I want to remove this word, right? So for that, I have written a special regular expression. Okay, so this is expression which start with hash and any word. Okay, this is the pattern. And if you write this, I have written a simple function, a simple Python function. Okay, so this will find the pattern using substitute. It will find the pattern in the given text, and I'm passing this pattern, and whatever it will remove, it will replace that pattern by simple empty string. Okay, this is what I'm doing here. So let me run this. It's very simple. I hope it's a Python. Okay, it's a simple core Python. So you can see that this is my source, and after this, it has removed this word and this word. It has successfully removed these two words because it finds the pattern. Okay, so it find, you can see I'm just printing the pattern as well. So it found these two patterns, hashtag and repeat performance, because it is starting with hash. So after removal, I have removed this from my given string object to ensure no this. Okay, so it removes successfully these two patterns. So this way it is very useful in the NLPK cleaning job task. We use heavily extensively regular expression. We create our own pattern. This can be your custom pattern, and use substitute function, and this way you can delete or remove any pattern, which is totally depends upon your business case. Okay, this is one example. Suppose I want to remove anything which is having at the rate. Suppose you have an email ID, okay, for example, like this, and I want to remove anything which is matching this pattern, anything which is having starting with at the rate gmail.com or any domain, right? I want to delete this, right? So I'm creating a pattern, and just I'm doing this. It will remove this pattern. This is very simple. This is completely Python regular expression. It has nothing to do with NLTK or any library. It is a core Python regular expression. Okay, suppose I want to split, I'm just applying this split. I want to split these two words by using this delimiter using at the rate. Okay, so sometimes we have to use, suppose totally depends upon the data. You want to play with the pattern, you identify that in my data these are the pattern which I don't want, I want to remove. So you can use regular expression, and this way you can create some custom function and you can play with it. Okay, you can remove the pattern and your data will be clean. This is a good approach. Okay, now let me talk about the punctuation. Okay, how to deal with punctuation, how to remove the punctuation from the data source. Okay, so to deal with punctuation, we have to import the string module. String has already a list of punctuation. Okay, if you run this, it will give a list of all the punctuation, this punctuation. Okay, one thing I want to talk about. Okay, so let's suppose I got all the punctuation, this punctuation. Okay, this is the predefined punctuation. Okay, so every punctuation has some ASCII code. Okay, let's suppose if writing provide me, I'm using a chat GPT, provide me all ASCII code for the given punctuation. Okay, so these are the predefined ASCII code for every punctuation. These are predefined in computer science. So you can see that for exclamation, for code, everything has a ASCII code. Okay, they have a integer number, corresponding integer number. Okay, so these are the predefined ASCII code, right? I think this concept is clear, right? So for every character, for every punctuation, I have a corresponding ASCII code. Okay, now here what I'm doing here, I'm creating a table. Okay, I'm just creating uh, a table with the ASCII code. Okay, and here I'm just I'm saying that create a table to remove punctuation. Okay, so this sentence str.make translation. Okay, and this will create a table just like a mapping table for this ASCII code. Here here my intention is not to replace anything, so I'm just creating a comma. I'm just giving blank. Okay, so this will create a table like this, punctuation table. Okay, ASCII table. Okay, after that, this is second step. So you got all the punctuation, you got the table ready. After that, you have to use a text or translate function. Okay, So let me combine here. Okay, so first thing what I need to do, I need to create the table first. Str.make transition, make translation. This will create a table. Okay, and then once the table is ready, then this is my original text which I want to remove the punctuation. So in this text, what are the punctuation? Like comma is punctuation, right? This marks, this exclamation marks as a punctuation. I want to remove this. Okay, so how to do that? Just you have to call text dot translate and pass that table which you already created, this table. Okay, so this will remove all the punctuation with empty, because I have given empty, right? Table empty, so it will remove everything and it will give just add a empty. Okay, so you can see that hello comma has been removed, world exclamation marks, this has been removed from the text. This is example dot, this is has been removed with punctuation, and this exclamation marks, it has been removed. Okay, so this is the approach to remove the punctuation. Okay, guys, you don't have to remember this code. This code is pretty much available, and I will share this whole code. You don't have to remember, just try to understand the concept. Okay, because these are this everything is kind of template. Okay, once you can create your own template, maybe your function or your library, and in your project you can use it. Okay, maybe this, because these are the predefined kind of template, you can pretty much use it. Maybe somewhere you have to use your own maybe your own uh, pattern or regular expression depending upon the data. Okay, for example, this is one example. Let's suppose you have a requirement. I have a this text, hello Sam. Okay, and here suppose I'm just making it. Okay, I'm just giving one example. Let's suppose I want to replace S with P. This is what I have requirement. Okay, so how to do that? It's very simple. Use a translate function and pass a table, a dictionary. Okay, so here I'm creating a dictionary. I'm just creating a mapping. So for S, okay, for the character S, what is the ASCII value? 83. Okay, let me prove that. Okay, what is the ASCII? Just see that what is the ASCII value of character S? It is 83, right? 83. So this is my character, right? 83, and I want to replace with P. So what is the ASCII value of P? ASCII value of letter P, capital letter. It is how much? 80, right? So this is what I have given. So I want to replace 83, which is the ASCII code for the S, with the ASCII code of P, which is 80. This is what I have done the mapping. Okay, so this way you have to prepare a table, a mapping, and you can do translate. It will remove. So instead of 83, which is corresponding to S, it will become 80, which will become P. Very simple. It's just a mapping. Okay, this is how we can play with the text. Okay. Okay, let me go to the next, which is very simple, white spaces. Let's suppose in the text, it can be possible, right? There could be some tabs, some white space in your text, in your source of data. So how to remove this? Very simple, just do a strip function. Okay, so string has a strip function, a very handy function. It will remove all the tabs, all the beginning or end from the tab. Okay, very simple. I hope you know the Python function. Okay, yeah. Let's suppose you want to remove some number. Uh, Suppose I don't want numbers in my text, maybe numbers, digits. I don't want digits. Okay, so how to remove the digits? So this is again a pattern. Okay, you have to create a pattern for digits. So this is I'm creating a pattern 0 to 9. This is again a Python. Okay, I'm creating a pattern for digits, and I'm removing it. Okay, because this was my initial function, right? To capture the pattern. Okay, to capture the pattern and remove it. Okay, so this way you can this is very handy. You can deal with any kind of pattern. This completely depends upon your situation. You can identify, this is my pattern, I want to remove with some word. Okay, so this is what I'm doing. It's very simple. So I'm removing the pattern. So 23 and this number 23 and 456, these are the number, right? So it will be removed, and 1 is also number. So banana, apple, orange. So I will get finally what? Banana or apple, orange. Suppose in my case I want to remove the numbers. So this way you can deal with the patterns. Okay, okay. Another important library is a num2 word. a library. Let's suppose you have, for example, let me give an example. Let's suppose you have this kind of sentence, this kind of text, okay? For example, a box contains 3 red and 5 white ball. Okay, so this is a number 3, 5, 4. This is a number. I want to convert this number into corresponding word 3. Okay, so it is a conversion from number to word. So in Python already we have one library called num2words, and just install this library, and it has inbuilt function just to convert number to word. It's very simple. Okay. Uh, so I'm just installing this library num2words, and it will help us to convert any number which is mathematical number, which is numerical number, into words. Okay. For example, here it is just a Python code. Okay, it has nothing to do with any NLP or NLTK. So I'm using numwords, a numword, importing it, regular expression. Okay, and then here what? Okay, here I'm writing a logic, simple logic. Okay, logic is like this. So here what I will do, I will okay, so I will I will get all the word. I will split the entire sentence, entire text into a small token or small words. Okay, and I will check whether the word is a digit or not. If the word is not digit, for example, box is not a digit. Okay, it's a pure text, so I will leave it. And if I find that any word is a numerical or digit, for example, 3, it's a digit. 5, it's a digit, right? So for those only tokens which are number, I will apply num2word, and num2word will convert these tokens which are numerical into text. A simple pure Python logic, right? So this is what I'm doing if you know Python. So here I'm splitting first. This is my input string. I'm splitting first. So by splitting, it will give you a list of words, a list of individual token, right? So I got the I, this is my token, right? And here I'm doing a check. If my I is a digit, if it is an individual digit, then applying num2word, convert into number, into word. Otherwise, else if it is not a digit, just leave it, just do nothing. And then I'm applying join function, and it will give me a result as a string. It's simple Python logic, nothing complicated, very simple, right? So you can see that the 3 has become word 3, THREE. The 5 number has become word 5. The number 4 has become word 4. Very simple. So it's very important library if you really want to deal with conversion, numerical numbers into text word. It will help you. Okay. So yeah, there are a lot of example like this. Okay. So it's very simple, right? Okay. Now move next. Camel case. Okay. Sometimes what happen? We have to convert uppercase to lowercase. Very simple. Okay. So Python has a every text has a lower, upper. Suppose you want to convert everything into lowercase, just try lower, otherwise upper. It's pure Python code. Okay, nothing to explain here. Okay, nothing much explain here. Okay, right. So now next is very important part, parts of speech tagging. Okay, which is the part of NLTK. Okay, what is parts of speech? If you know the grammar, English grammar, every word has some grammatical presentation, right? Suppose it has a somebody can be, some text can be, token can be noun, verb, adjective, preposition, right? So how to identify that particular token in my given text or given sentence, or which grammatically they belong to? I mean, they belong to noun, they are noun, they are verb. How to categorize, how to find the grammatical presentation of that token? So that, for that purpose, we use parts of speech. Okay, so it has inbuilt feature, you don't have to do anything for that, it has already trained model. So NLTK will do that. Okay, for example, this is one example I have taken. For example, this is your sentence: the quick brown fox jumps over the lazy dogs. Okay, dog. Okay, and I want to find the presentation for each word, which grammar they belong to. For example, D, it's a determiner. Okay, okay. Quick can be an adjective. It's an English grammar. Okay. Brown, it's an adjective. Sorry. Fox. So fox is a noun, jumps is a verb, over is a preposition. These are other determiner, right? Lazy is adjective, dog is a noun, right? It's a pure grammatical presentation, right? So sometimes suppose I want to get it that for my given text, I want to find, I want to do tagging, okay? I want to classify it as a which parts of a speech they belong to sometimes, okay? So that case you can use in that is a scenario. How to use that's very simple. So NLTK has given a library called parts of a speech tag. Okay, that's what you have to use, and you to have some couple of uh, corpus like punctuate and average percentage tagger. Okay, these are the things you have to download. Okay, to do that, I done that. Okay, now here. Let's suppose this is the code is very simple by the way. Let's suppose this is the syntax. This is the code I have. NLTK is a powerful library for natural language processing. Okay, this is my text, and I want to classify. I want to tag every tokens uh, grammatically. Okay, that I cover. Okay, so how to do that? So what I'm doing here, first I'm converting every token. I'm using word tokenizer. I want to get all the tokens. Okay, and for each token, I'm passing into pus underscore tag. It's an inbuilt function for tagging, for parts of a speech tagging. Okay, so that's what I'm passing here, and it will give me all the tags. It's very simple, right? They have a already inbuilt functionality, so I'm just using it. Okay, so you can see that NLTK is noun, is a verb, a is a determiner, powerful is an adjective, library is a noun. You can see this way it is giving uh, all the tagging for each token. Sometimes we will use it. Okay, so how where to use this tagging I will cover in the generally be used in the lemmatization. Okay, which I'm going to cover next. Okay. All right, so I think you guys are with me. So that's yeah, let me remind what we have covered. We started with the tokenization, word tokenization, sentence tokenization, white space, punctuation tokenization, removing the stop words, what are different stop words, okay, how to remove punctuation, spatial marks, using the pattern, regular expression, punctuation we understand, white space, number replacement, okay, how num to words library, right? How to replace that, how to convert case, lowercase, uppercase, parts of a speech tagging. Very simple, right? Now let us think about this is very important, and this is very important part of data preprocessing. One is called stemming, and one is called lemmatization. Okay, there are two things: stemming and lemmatization. Okay, so what is stemming? Let me explain that. Okay, it's very simple, by the way. It's not rocket science. It's very simple. Let's suppose if I write a word, suppose playing. Okay, playing. Okay, so here playing is a word, English word. If you know English, we find the root word. What is called root word? Okay, if you know in English grammar, I used to remember like what is the verb one, verb two, verb three, verb four, right? If you remember in English, right? We have a play. Play is verb one. Okay, there will be played, verb two. I think playing, what is the verb three? I think it is also played. Okay, verb three and verb five. Maybe I'm making mistake. I don't remember. But this way, we in English we generally memorize this kind of multiple forms. Okay, so verb one is a root verb. Okay, this is the root verb. Okay, it's a root verb, and from the root verbs, from the root word, we can create from the root. We can create multiple words, right? Multiple words. For example, playing, right? So playing is a word. For the playing word, what is the root word? What can be the root word? Play, right? Play, right? So this way, for a given word, we can find the root word, right, in English. So this is the concept of called stemming and lemmatization. Okay. So what is stemming? So there are two approach to just find the root words. There are two approach in NLP world. Okay. One is called stemming. So a stemming is very straightforward, very simple. What it does, it just remove the suffix, the last word. Okay, it just remove the suffix 6 from the last word, and it gives some it gives some word. Okay, for example, if I say playing, okay, for example, let's see, let's suppose if I say playing, right? Let's suppose if I say communication, communication. Okay, so what the stemming does, that's the difference between stemming and stemming and lemmatization. I will cover. Okay, so what the stemming will does, so stemming will, what will do, it will, they have some rule. Okay, they will remove some last word. Okay, and from the communication, it will provide a root word, maybe commune, like this, commune. Okay, so it is just removing the cation. So this portion, this affix, this is removing the last few word. So they have some predefined rule to remove some word. Okay, so they will remove some last few words, last few tokens, and it will give you a root word. Okay, the problem with the stemming is that there's some problem with the stemming. Okay, stemming is very fast, to just because they have some fixed rule, so execution is very fast, is very fast. Okay, but the problem is, the biggest disadvantage of stemming is that it will give you root word. Okay, but this root word has no grammatical meaning. Okay, maybe it is, you will get some word which has no any context, which has no any meaning at all in that language, or it is not part of the dictionary as well. Okay, for example, commune. Okay, communication is a part of dictionary, it has some meaning, but if I say commun, maybe it has no any meaning. Okay, so sometimes this is a problem. Stemming will give you some word which may be not the part of English dictionary, or maybe that word has no any contextual meaning, or maybe that word may not exist at all. It is quite possible. So that is the problem with the stemming. Okay, so what will happen, what will happen if you get some word which has no meaning, which has no contextual meaning, and if you're building a model on this word which has no meaning, your machine will not perform well, your performance will be not good, because that word is not capturing any contextual meaning from the given word. Okay, so the machine will not give a good prediction. So that is why we generally don't use stemming, but the stemming is very fast. Let's suppose you want to get the fast performance, then you can use the stemming, but this is the whole concept. Okay, so in the case of a stemming, it will remove some word, they have some fixed rule, but maybe that word, there can be chance that word cannot be the part of any dictionary, or that word will have no contextual meaning. So in that cases, maybe sometimes your model performance can go down, it will not give a good prediction. That is the case. Okay, for example, let me show. For example, this is my input string. There are several types of stemming algorithm for natural language. Suppose this is my source of data. Okay, and here I'm applying some stemmer. There are a lot of stemmer, like Porter stemmer. Okay, and from the stemmer, I'm just creating a token. I'm just creating a word token, and for each token I'm applying the stemming, this is stemming. Okay, and it is producing this. Okay, so let me run this. So you can see that this token there, it become there, r become r, several, you can see that for the several it is converting into sever, sever. Maybe it has no meaning at all in English dictionary, right? So the machine will not understand, there's no any contextual meaning. Types becomes type. See, in the types, it just remove the s, it just remove the s. Okay, off become off, same. Stemming, so in case of a stemming, it has removed the MING. They have, I told that they have some rule. They will, on the basis of rule, they will remove the last, maybe they determine, okay, which they want to remove, and they will give some word. So stem. Okay, algorithms, for the algorithms, it is removing the s, and the root will become algorithm. Four become four, natural is natural. Languages, okay, these are plural. So for the languages, it is converted into language. Maybe this language, maybe spelling is wrong. Okay, so this way, the whole concept is, it will remove some last word depending upon their fixed rule, and the resulting word which you're getting as a root word, maybe that word is not the part of dictionary, that part has no contextual meaning. And this way, if you're building a model, maybe your model will not give a right prediction. So this is the problem with the stemming. That is why generally we don't use stemming. I have seen this. This is the error with the stemming. Okay. So how to overcome that? Just to overcome that, we use lemmatization. And generally, if you're doing sentiment analysis, where your contextual meaning is very, very important, I will highly recommend use lemmatization. Don't use stemming. Okay. And generally I have seen most of the cases, more than 90% cases, generally we use lemmatization. So lemmatization, how it works, it will give you proper, it will I mean the root word which you will get after the removing the last word, it will be accurate word, it will be the contextual word, and it will be the part of English dictionary. So that is the advantage. Okay. It will not give any random word. Okay. For example, how to use that? Simple. You have to use word. Okay. We have to download WordNet. It's a corpus. Okay. These are things you have to download. These are prerequisite. Okay. And then we have a WordNet lemmatizer. So this is what we have to use. Okay. WordNet lemmatizer, and then lemmatize it. Okay. So again, so this, suppose this is my text, I will convert into tokens using word tokenizer, and for each word tokenizer I'm applying the lemmatization. Very simple, very code is very simple, right? And I got the lemmatization. Let us see how it works. Okay, so this is my original word, right? The cats were running faster than the dogs. This is my original. So how it is converting? The become the, cats become cat, where become where, running become running. Okay, in case of uh, stemming, running will become run, but it is giving running. Faster will remain faster, than become than, the dogs, I mean it is almost same. Okay, the dogs become dog. Okay, so this is how, I mean it will give you very accurate word after limitation. It will give a very accurate word which is the contextual meaning. Okay, and generally we use lemmatization generally. Okay, one more thing here, generally we combine lemmatization with the parts of speech tagging. Okay, you can see here while I'm using lemmatizer, okay, I'm just passing the word. Okay, and let's suppose, for example, running. Okay, I want to convert running into verb. Okay, which is not happening right now. It is converting running into running. Okay, but I want to convert into, I want to get the root word, and while getting the root word, I want to get the grammatical presentation, whether it's a noun verb, the same. I want to do both. Okay, so in that case, if you have that requirement that you want to get the root word with the proper parts of a speech, then you can combine lemmatization with the parts of a speech tagging. How to do that's very simple. So here, while applying the lemmatization, pass the word. Okay, and you have, for example, let me show example. Okay, it's very simple. Let's suppose meeting. Okay, and meeting word I want to convert into root word, and I want to get the noun. Okay, so meeting will remain meeting. Okay, lemma is not defined. Let me run lemma. Yeah, let me run this. Okay, okay, you can see that here what I'm doing, played word. Okay, I want to get the root word of played with the as a verb. So played will become play. Okay, for example, meetings. I want to get the meeting as a noun. Okay. Player, I want to get as a noun. Players, I want to get as a noun. Okay. Better, I want to get an adjective. So it will become good. So better will become good. Okay. So it's very handy. You can combine lemmatization with the parts of speech tagging, and you can determine that, okay, I want this word as a root word along with this part of speech tagging. You can combine this approach. Okay. So here what I'm doing here, I'm written a custom function, okay, which is doing the same thing. Suppose I have this bunch of sentence, and for each token, I want to get lemmatization, and I want to convert into corresponding parts of a speech, okay. So, okay, this is what I'm doing here. This can be a bit not complex, very simple. Okay, let me explain what I'm doing here, okay. So what I'm doing for this sentence, First, I'm converting into tokens, word tokens, by each word tokens, and for each token, I'm getting the parts of speech. So I'm using parts of speech tagging from the NLTK. So I want to understand for this sentence, for this token, what are the parts of speech. So I got all the token parts of speech, right? And here, what I'm doing, I have written some custom mapping. Okay, if the tag start with J, then I'm saying it's an adjective. If I start with V, I'm saying it's a verb. So I'm just doing a mapping here, very simple. And here what I'm doing, the tokens which I got it, for each token, okay, I'm doing iteration. I will get the word and I will get its corresponding tag, okay. And here I have custom, if the word is R or it is on M, I'm just using it, okay. I'm not using any lemmatization. And otherwise I'm doing lemmatization, and along with the lemmatization you can see that I'm using lemmatization, I'm passing the word, okay, and for that word I'm getting the parts of speech also. So I'm passing both, okay, I'm combining both the word and parts of speech at the same time. So this is just like this, okay, just like that, okay. So this way you can combine both parts of the speech along with lemmatization, okay. But it is very useful. It give very grammatical correct word. This way uh, you can convert into root word. Why it is important, okay, why we are doing this whole thing, why we are converting into root word? Because it will take less space. So for example, if I saving, suppose I'm getting playing, okay, if I convert into play, it will reduce the memory consumption. Even I'm not losing the context also, okay. It is not that I'm losing the context, I'm losing the meaning. I'm getting the meaning also, at the same time I'm saving my memory as well. So that is why it is important. This all pre-processing is required, okay. So these are the basic pre-processing I cover. One thing I want to cover, last one, is the visualization part, okay. So if you really want to see the presentation, suppose you have a text message and you want to see the uh, that presentation of each word, each token, which word has given the more importance, okay. So there's a very handy tool called WordCloud, okay. It will give a very nice visualization. It will give you the important word, it will highlight, okay. So how to use it? Very simple. So first of all, you have to install it. I have installed the WordCloud, okay. Generally we use this for our analysis process. Suppose I want to analyze the text, how it looks like in my text, what are the weightage of my text. So it is just for analyzing, okay. So here I'm using WordCloud, and along with WordCloud I just want to plot the entire text. I'm using pyplot, okay. Let's suppose this is my word, this is my text, okay. This is my text. So you have to initialize, first of all you have to initialize the WordCloud object. You have to give some width and height, okay, some background. And here one thing, this stop word, it is optional. Let's suppose if I don't give a stop word, okay, but these are the pretty much these are pretty much is required. Create a word cloud with some height, with some width, and give some background, okay, and then call generate and text, the pass your text, very simple, okay, and it will give a nice visualization. And then I'm using some pipeload. I'm giving some canva, I'm creating some figure. I'm just creating it, okay. So let me run this. So you can see that for this given text, okay, it is giving you this kind of visualization. So what does it mean? That you can see Python, okay, this is highlighting very upfront, like language, Python, okay. So you can see the Python. So maybe what is showing that this Python has a, maybe they are more weightage, maybe they are more repeating, okay. Along with that one, okay, just to showcase, along with that, what I'm doing here, you can also use counter, okay. There is a collection framework, okay, you can use counter. So the counter will help you to count the frequency of each word, okay. So I'm using a counter here. Let's suppose this is my text, okay, this is my same text, Python, this whole text, okay. Here I want to check what is the frequency of each word. I mean, Python, how many times they're repeating. Is easy to learn, how many times repeating, each how many times repeating. I just want to count the frequency. So if you really want, it is only for analysis purpose, that which word having more weightage and which word is repeating most of the time. I want to do that kind of analysis. Okay, so you can use, suppose you can use counter, it's very handy. Okay, and I'm creating first token for the given text. I'm converting into token, word tokenize, and passing all the token into counter. Okay, this counter give you a map. Okay, this counter will be give a map of each token and along with their counts, their frequency. So what I'm doing, I'm just sorting it. Okay, I'm sorting all the items, whatever I got, the it's a map, so I'm using items, and I'm sorting in the decreasing order. Okay, one second, let me show once again. Let me try this without it, so you will get some idea. Let's suppose I got this object frequency, right? I just want to count the frequency. Let me print this. Okay, so this is what I'm getting, right? So here I'm getting Python 2 times, is 4 times, a 1 times, easy to learn. You can see it is giving each token frequency. I mean, each token, how many times they are repeating. Okay, let's suppose I want to sort it. I want to sort by the value. This items I want to sort on the basis of value. I mean, decreasing order. That's what I was doing right now. So I'm sorting it. Okay, I'm taking the items, I'm sorting it. So if I sort it, you can see that each is coming 4 times. Okay, I'm sorting by the value of decreasing count occurrence. So 4 these two words, is and dot comma, it is repeating most of the time. It's 4 times. Okay, Python 3 times, and 2 times, right? Easy to learn 1 time, and all the words token are repeating, I think mostly one time, right? Programming, everything repeating 1 time, right? So this way I can find the distribution of given text in the given the text, the token, what are the distribution of the token in that given text. Is it will give me understand that, okay, if something, suppose if I find that, let's suppose each, okay, and this dot, I found this, the dot is repeating 3 times. Maybe this dot has no importance, no much contextual meaning in the given text. It is unnecessary taking a lot of space, right? So let's suppose I have a 3, instead of 3, let's suppose I have 3,000 times coming dot dot. So why to keep it, right? I can remove this, right? So it will help me to inspect, analyze the text, that which word, which token has more importance, and which token I should remove. So it's kind of inspection. We are inspecting it, right? So that is what it is doing, right? You can see that. So Python, because here Python is repeating how many times? 2 times, right? 2 times, right? So that is why it is highlighting Python here. For example, language, right? Absence language, how many times? 1 time. Okay, so it is giving importance. Okay, otherwise here one you can do, you can also give here stop word. Okay, they have a option for stop word, so you can stop words, right? So what is my stop word? I have initialized with this stop words, so it will filter out the stop word while creating the word visualization. Now it is giving you very clear. Okay, so you can see that after all the filtration of like all the stop word, I can see that Python is it is giving more weightage for Python, learn, programming. So from just from this picture, this visualization, you will come to know that, okay, Python has more importance, programming language has more. So what is talking about? Okay, this whole text is talking about what topic? It is talking about development, it is talking about Python, it is talking about machine language, it is talking about programming language. So I can get the whole glimpse, okay, as a visualization. So that's why it's very handy. It's very useful just to analyze some text data. Okay, and and then you can make some decision. Okay, and I also find this is also very handy, the filter, the frequency count. Okay, this is also handy, this counter function, and it will give you all the number of tokens, how many times they're repeating. Okay, so this is the whole thing. Okay, this is the all basic things I cover to how to do data processing, data normalization. Like I cover tokenization, I cover stop word, removing stop word, I cover like removing the punctuation, special symbol using patterns. It's very important. Punctuation removal, white space removal, right? Number to word conversion, uh, converting the case, part of speech tagging, and very important is stemming and lemmatization. I hope you understand the difference between stemming and lemmatization, and which is important, which is not important, right? And visualization I covered with help of WordCloud, okay? And it is very handy. Okay, so this is all about data processing. There are a lot of things which is maybe not much important, okay? But yeah, these are the most important parts, which is a part of data pre-processing, or these are the important library of which you can use from NLTK. And this way you can clean your data, you can normalize your data, and then you can pass to the next level, can be the model building. Okay, so this is very important. In next class, we will see couple of more kind of use cases, because it was only kind of theory. I will give us some kind of small project where I will apply this whole pipeline. Okay, how to do, how to apply everything in one shot, in one project. Kind of dummy project we will do in the next class. Okay, so this is all in this class. I hope you got all the understanding. It was a very important. By the way, this is a very important part of the NLP pipeline, how to do data pre-processing. Okay, this is all in this class. I will see in the next class where I will cover a small, very kind of small project to data pre-processing using NLTK. Okay, I will see you in the next class.